Welcome to WSHS Algebra 1 Virtual Tutor. Today we are going to be talking about translating quantitative situations into algebraic expressions and vice versa. So we first have to look at our mathematical operations and symbols. We have addition and our symbol is a plus sign. Other words that mean addition are plus, sum. Remember, sum is the answer in addition. Add. And then our special word is the word more than. More than tells us to start from the back and work to the front when we rewrite the expression. Our next word is subtraction. We symbolize this with a minus sign. Again, minus is one of those words that means subtraction. We have the word difference, which is the answer in subtraction. And then we also have the word less than. Again, less than is like more than, and you start from the back and work to the front when you rewrite the expression. Next, we have multiplication, and we usually symbolize that with a dot, or sometimes you can see parentheses with parentheses. The answer in multiplication you would say is product. And another word you may use for multiply is times. Again, these are just a few examples. There are more. Division, you can symbolize with a division sign or with a fraction bar. The answer in division would be quotient. You could also say divide as well. Parentheses, we represent parentheses with the word quantity. So we're going to represent parentheses with the word quantity. And then other things like the word sum, difference, product, and quotient you may also see in parentheses as well. Squared is when we take something to the second power. So squared is when you have an exponent of 2. And you can say raised to the second power. Cubed is something raised to the power of 3. So you, again, could say raised to the third power. Square root is the inverse of squaring something. So your square root sign looks like so. And this is what we symbolize as a radical. You may hear the term radical as well, which is a square root. Cubed root, the only way we say cubed root is cubed root, but the cubed root has an index of 3, so that's a little 3 that goes right in between your radical sign there. Moving along in example 1, we have writing an algebraic expression. So basically what's happening is we're given the verbal form of it and we need to write it mathematically. So A says 7 more than n. Remember, more than means plus, but we start from the back and work to the front. It's a switch word. So that means we look at the back of what happens after more than, and that's an n. So that's going to come first. And then the 7 is going to come last in our expression. So it's n plus 7. The difference of n and 7, remember difference means subtraction. And this one just goes in order from left to right. So n minus 7. The quotient of twice a number and the cube root of y. Quotient means division. So we have the quotient of twice a number. How do we represent twice? That's 2 times a number. Let's make a number x. So you have 2 times x and the cube root of y. So quotient is division. 2x on top, and the cube root of y would look like so. Cube root with a y. And now we have the word quantity. The quantity, which means parentheses, of a number n minus 8 divided by x squared. Okay, so the quantity n minus 8 in parentheses divided by x squared. Now you guys take a second and do the you try, and I will do it out loud. The sum of double a number and 31. Double is just like the word twice. Okay, it means multiplication of 2. So you have 2n. The sum means addition, and you put that plus sign where you see the word and. So 2n plus 31. Letter B says the product of 1/2 a number, so 1/2 n would represent 1/2 a number. Product means multiplication, so times the cubed root of the same number. So because it's the same number, we have to use the same variable, which is n. For example 2, we are writing a phrase for each algebraic expression. Now just note your answers may vary here. You may not put the exact same thing as I do. But I find the easiest way to do this is to simply read the expression out loud to yourself, and as you say it out loud, you write it down. Again, when you have a coefficient and variable right next to each other, that operation that's occurring is multiplication. So if we look at letter A, you can say the quotient of 3 times a number and 9. The quotient is telling us to divide. 3 times a number is your numerator, and is where your division sign goes, and 9 is your denominator. The next one, we have parentheses. So remember, we use the word quantity to represent the parentheses. So we say the quantity of a number minus 3 times the quantity of a number plus 6. Letter C, we have 5 times the square root of a number. And letter D, we have 2 times a plus x cubed would work for that. For the you try, we have x squared, so you can say x squared minus 15. And for letter B, you would say the cubed root of x plus 1/2 x would work. Again, there are multiple sayings you could use for this, so it doesn't have to be identical to what I wrote. Example 3 is where we have our word problems, and now you're looking at writing algebraic equations for real-world situations. So remember with the word equation, we use equal signs here, and we're just setting up the problem. We're not actually solving it all the way through. The total length of rope in feet used to put up tents is 60 times the number of tents. So we have the total length of the rope. So T, let's make that the total length. Is used to put up tents is 60 times the number of tents. Let's make N the number of tents. And 60 times, so that's saying 60 times the number of tents, N equals how much rope you need. So that would be T, the total length of rope. And then that's all we have to do. If we look at letter B, it says the length of a rectangular classroom floor is 5 feet more than 3 times the width. So let's just start there. The length, L, is means equals 5 feet more than. Remember with the word more than, you have to start from the back and go to the front. So what's in the back, the word than, is 3 times the width. So we represent that as 3W. More than means plus, and 5 goes in last. Because we look back, what came first? The 5. That's the first sentence. The second sentence says the area is. So we're going to say A equals, area is 80. And then it says to write an equation that represents the area of the classroom floor. So what don't we know? We know A, we know L, but we don't know W. So we're going to represent W as W. And now that we have this, we have our A labeled, we have our L labeled, and we have our W. So we insert this into the formula A equals length times width. So instead of the L, I'm going to substitute in 3W plus 5, and I'm going to put that in parentheses because it's the whole quantity. And then for the W, I'm inserting in a W. And for the A, I inserted in the 80. So now we have our formula for area here. For the U-try, we're asked to find the perimeter of a rectangular pool is 60 feet. So we know P perimeter is P equals 60. The length, so L equals is 7 less than twice its width. Again, it's a switch word, so we have to start from the back. Twice its width, 2W, less than is minus, and 7 came in the front. So L is 2W minus 7. It says write an equation that represents the perimeter of the pool. It gives you the equation for perimeter. So now all we do is we plug in. Again, what don't we know? We don't know W. That's our question mark. So we're going to represent W as W. So if I take my formula, P equals 2L plus 2W. For P, I insert 60 equals 2. And then for L, we're inserting the whole thing, 2W minus 7. Again, I put that in parentheses, plus 2 times W. Now I'm going to take the time and I'm going to simplify this a little bit further. So you get 60 equals, we're going to distribute the 2 to both values here, 4W minus 14 plus 2W. And then from here, I'm going to combine like terms on the same side. We have 60 equals 4 plus 2 is 6W minus 14, and that would be a good answer. Okay. So that's using your word problems with area and perimeter as well. Let's look at some practice problems here. Number 1 says write an algebraic expressions for each phrase. 13 more than the product of 2 and J. More than is your switch word. So you start from the back and go to the front. So look at what comes after the word than. The product is multiplication of 2 and j. So again, that multiplication sign is going to go in between the 2 and the j. So 2 times j more than means plus, and 13 comes last. Number 2, it says 8 less than the quotient of 4 and p. Again, the word less than, that's one of those switch words, okay? So we start from the back. The quotient. Quotient means division. So that division sign goes where the and is. 4 divided by p minus 8. Again, you're taking 4 divided by p minus, less than means minus, and then what came first is then last in your algebraic expression. Number 3 says write a phrase for the algebraic expression occurring. So this time we have 4. You can say times the quantity. Remember, quantity means that word parentheses. 4 times the quantity of x plus 3. And that's as simple as you can make it. Again, you can make it a little bit more complicated if you would like to, but you don't have to. Number 4, it says write an algebraic expression for each phrase. The length of the rectangular classroom floor is 12 feet less than 3 times the width. Again, let's break down this sentence. Length is, so L equals 12 feet less than's a switch word. Start from the back and go to the front. 3 times the width, so that's 3w minus 12. Which expression represents the area of the classroom? This time we don't know area, so we're just going to keep A equals A and W equals W. So we're going to plug into our formula. A equals length times width. Again, this time I do not know what A or W is, so I'm going to keep it the variable. A equals, instead of L, I'm plugging in 3W minus 12 times W. And if you know how to distribute, you can distribute this W. A equals 3W squared minus 12W. And that's a little bit more advanced than what you would start off with in Algebra 1. But if you know how to distribute, go for it. And that is translating algebraic expressions and vice versa. There's practice given to you as well, so please complete the practice so you have full understanding of the concept. Thank you.